2 now, okay? And so what we're going to talk about today is a little bit about the conversion sheet. We're going to talk a little bit about the sig figs. And the last thing is this whole idea of factor labeling and dimensional analysis. I just want to make sure that you understand that it's a problem-solving method. And the only way that you're going to get to be good at this is by practicing. And so I like to use the analogy of bike riding. And my son, my youngest, he was 7, and I took him out, and it was the fall last year, and we went, and I was trying to teach him how to ride a bike. And so I take him out, and he pretty much had it. I let go, and he started riding, and I was like, yes, he's got it. Well, really soon after that, it got super cold. And so we didn't get a chance to go out after that point, but I definitely let go, and he was on his own for a little bit, okay? So the next time we pull the bikes out, it's pretty much springtime. And so I'm like, hey, bud, remember riding bikes? And he was like, yeah, let's go. So he gets on and falls and could not get back on. And I'm like, I don't understand. Like, you had this before. But the problem is, what was he not able to do immediately after? Practice. Now, we know that we could not ride a bike for months and we would still be fine. But we've got it down. If you don't really have it down, and you don't keep on practicing immediately after, it really is like starting over again. And we did really have to start over again. And it didn't just take a couple of days. It actually took a couple of weeks for him to get it down. It was almost like we were starting back over again like we did in October, November. And I was like, what is going on? This is ridiculous. But it's true of stuff like this too. You learn it, and unless you practice it, you're really not going to get it down. And how many of you have tried to watch someone do something and go, yeah, I can do it, and then you try and you're like, ooh, that was a little more difficult than I thought. Has this happened to you? Whether it was doing a handstand or a headstand, or maybe it was something like riding a skateboard or snowboarding, okay, skiing, anything like that where you're like, yep, that looks great, I could do it. And then you get on and you're like, ooh, that was a little bit harder than I thought it was going to be, okay? So similar thing here, you can watch me solve the problems and I can help you with the problems, but I'm still holding on to the back of your bike, okay? The only time you truly know whether or not you're going to make it on your own is if you, from beginning to end, solve a problem on your own, okay? Otherwise, so I had people that came in and they're like, I just don't know how to get started. That just came in during lunch and said, I don't know how to get started. And I said, I'm going to guide you, but I really, really, really want you to be able to do it on your own because, again, it's like me holding on. Okay? So what we're going to do today is we're going to do a whole bunch of problems together. Every single problem is going to be different. So the more exposure you get, the better you're going to be. But I really want, even though I'm going to do these problems with you, I'm going to stagger it a little bit and I want you to try it beforehand on your own and then I'm going over it. Okay? So if you want to get started on some of the problems that we're going to be working on, that's awesome. That's probably your best bet. So get started. I will be talking. And then if you find that you're getting stuck, where is that point that you're getting stuck? Then you can kind of look back up and see, how did she do that? How was it that she was able to keep on moving? And again, for me, this is like riding a bike, okay? So, or similar to you, riding a bike, where a kid that's never been able to ride a bike, it's going to take a little bit of time to get them moving, okay, to get their balance down. So let's start off with this conversion factor with this sheet right here, and I just want to give you a little heads up as to how I have this set up. So it's set up by mass, length, volume, temperature, and time is down at the bottom. And here we have English, we have International System SI, and this is English 2 SI, okay? When you're switching with English, let's talk sig figs really briefly here. When you're switching with English, what they did was they actually defined certain things like 2,000 pounds is called a ton. It's not 2,000.023456. They actually defined, they said 2,000 pounds is 1 ton by definition. So these are going to be an infinite number of sig figs going down here. So to say that there are 12 inches in a foot, it was defined that 12 inches is 1 foot, not 12.02, not 12.12, not 12.32, 12.00000000, repeating, infinite. Here, these are also definitions. So when they said that there were 100 centimeters in 1 meter, it was exact, okay? So if we say that 1 gram is 1,000 milligrams, it's exact. This is also an infinite number of sig figs going all the way down. The only time that you're going to use sig figs is when you're switching between English and SI. because now it's not exact. If you're trying to convert from ounces to milliliters, it's not exact. I'm giving you a conversion at 29.6, but if you look it up online, that number keeps on going. Same thing with liters to gallon, that number keeps on going, okay? And you might be able to find a conversion like miles to kilometers. You can see here that I've got kilometers to miles here, where I set it, so it's 1 mile is 1.609 kilometers, or 0.6214 miles is 1 kilometer. So you'll find different numbers, and some people say 0.62 miles in a kilometer. So you can truncate that number, you can cut it off, okay? So those we're using sig figs for. We're not using sig figs for either of these. Good? Okay, so let's go back and let's just start working on some problems. So we are done with the notes. The only thing that you need to know, okay, is circle what you want, write what you got, throw in a bridge, cross units opposite. Everybody say it with me. Ready? So if you need to read it, you can. Here we go. Circle what you want, write what you got, throw in a bridge, and cross your units opposite. That's one thing, okay? That's one thing about these story problems. And the only other thing that you need to make sure that you remember is if you're ending with 1 unit, then you need to make sure that you're starting with 1 unit. If you're ending with 2, you need to start with 2. That's it, okay? That's all you really need to know, and then it's a matter of you just working out the problems and solving them. So let's try this problem down here. It says that a light year is the distance that light travels in 1 year. Make sense? If the distance of the sun is 1.5 times 10 to the 8th kilometers away, how many minutes will it take for light to travel from the sun and hit the earth? How many minutes do you think it takes? If you already calculated it, then don't say. So if you already calculated it, then around how many minutes do you think? Just take a guess.
8.
Oh, good. Maybe you calculated, but that's good. Nice, awesome, nice. Oh, you know it. Good, perfect. Okay, so let's see 8 point something, what it is. And we're going to assume that light travels at a speed of 3 times 10 to the 10th centimeters per second. So what we're going to do is we're going to underline our numbers. I see this right here. I'm going to underline that it's 1.5 times 10 to the 8th kilometers away. And I also see this 3.0 times 10 to the 10th centimeters per second. You can write all of your values on the side if that helps you. Okay, you don't have to. But if that helps you, you can do that. So step number 1, circle what you want. What unit are we looking for in this problem? Minutes. Perfect. It says how many minutes. So you're looking for a question. Okay, when you're trying to analyze a problem, you're looking for how many, how much, and you're looking for a unit. So in this case, it's minutes. We're going to circle that. And I like it here in the margin because I just can keep looking back to the left instead of looking back at my problem, okay, at all these words. Where are you going to start? Well, we have 2 places that we can start. On the count of 3, you can either say we're starting at the kilometers or we're starting at centimeters per second, okay? On the count of 3, I want you to say whether you're starting with kilometers or centimeters per second. If you're ending with 1 unit, you need to start with 1 unit, okay? On the count of 3, which one of those is 1 unit? 1, 2, 3.
Kilometers.
Kilometers, perfect. So we're going to start with the 1.50 times 10 to the 8th kilometers. Throw in a bridge and cross the units opposite. So I've got kilometers. So I analyze the problem, and I'm looking for a link. I'm looking for a chain or a link from kilometers, but I don't see one. I don't see kilometers in there. Is there something related to kilometers in the problem? What do you see?
The centimeters.
Centimeters. Perfect. We see that there are centimeters right there. So if we can link kilometers to centimeters, if we can switch our kilometers to centimeters, then we can use that value right there. So let's do our kilometers to centimeters. So go back to your conversion chart, and you flip over to the back here. Let's do a couple of these together. So if I'm going from giga to kilo, what would that be? 10 to the 6. And you just subtract the 2 if they're on the same side. If they're on opposite sides of base, you have to add them. So let's say I'm going from mega to micro. What would that be?
12.
10 to the 12. What if I were going from deci to nano? What would that be?
8.
10 to the 8. So if they're on the same side, subtract. If they're on opposite sides, you're going to add. So these are on opposite sides. I'm going from kilo to centi. And what is my exponent? 10 to the 5th. Perfect. So let's come back here. And remember what we said was, you're going to put the number 1 with the bigger unit. And then the smaller unit is going to get your exponent. Really easy to remember because all you need to do is think of any conversion example that you already know. For example, 60 seconds in a minute. The minute is bigger, it gets the 1. 60 minutes in an hour. The hour's bigger, it gets the 1. Okay, anyone that's bigger gets the 1. So if we come back down here, then we're going to put what with the kilometers? 1. Why? It's bigger. And then 1 times 10 to the 5th is going to go with the centimeter. Kilometers cancel out. Awesome. I'm not done because I want minutes and I'm in centimeters, so cross that opposite. Now I'm going from centimeters and I'm going to analyze my problem and check to see is there a link to get me, and you can't change length into time unless you have some type of rate. So that's what we're basically looking for, which you don't even have to think about that because you're just going to find the link in the problem. And what do you see? What's the number? 3 times 10 to the 10. Awesome. Now here's the question. It's centimeters per second, okay? Remember, similar to saying 60 seconds in a minute, it's incorrect to say 60 minutes in a second. Okay, keep that in mind. So where does the 3 times 10 to the 10th go? Does it go with the centimeter or does it go with the second? Centimeter. Awesome. It's going to go with the centimeter, 3 times 10 to the 10th centimeter, because it says per second. When it's per second, it's per how many seconds? 1. Awesome. That's just per 1 second. Okay. That means that it's traveling that many centimeters every 1 second. You count 1, it's traveled that many centimeters. It doesn't make sense to do it the other way around. Okay. So now we're in seconds, but we're not done. We're almost there. What's the last thing we need to do? Minutes. Seconds to minutes. Awesome. And you know this. You don't have to look at your conversion sheet. How do you go from seconds to minute? 60 seconds in 1 minute. And now we're done. And all we're going to do is multiply and divide. Please make sure you try this in your calculator. There were people in the other hour that were getting the answer wrong. They were off by 1. So in your calculator, what you should be doing is, remember we're using E, okay? 1.5 or 1.50 E8 times 1 E5 divided by 3E10 divided by 60 equals, okay? So what are you getting in your calculator for this?
8.3 repeated.
Awesome. You should get 8.3 repeating. Okay? So now we're going to do sig figs. This is a decimal number. Okay? 0 at the end, on the right, at the end of a number counts, right? So how many sig figs is that? 3. Okay? This is a definition. It's an infinite number of sig figs. So this, because we got it from that metric part, that's an infinite number of sig figs, meaning that that's a lot, okay? This is a decimal number. They actually truncated this number. I truncated it, okay? If you look online, they'll tell you that the speed of light goes out further. You can go out further with it. So how many sig figs is this? 2. And 60 seconds in a minute. Is it 60.0, 60.012, or is it exactly 60? Exactly 60. That means it's an infinite number of sig figs. Anytime that you have a definition, something that's exact, it's an infinite number of zeros that would come after. So your answer is not going to be based on the bigger one. I call it the LSD rule. It's the least number of sig figs. What's the least number of sig figs? 2. So I need to round this to 2 sig figs, which means my final answer is what? 8.3 minutes. Perfect. 8.3 minutes. Got it? Okay, so what we're going to do next is we're going to problem solve. I want you to start working on the problems, though, before I do. So I'm not going to do all of them. I'm going to pick and choose a few of them to do. Okay, so let's start with this one right here. Convert 70.3 grams to milligrams. Now, this could be written as a huge problem. It could be a big story problem, okay? It could say something to the effect of, you have some coins that you decided to weigh on a balance, and they weigh 70.3 grams, but you want to convert that into milligrams because blah, 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 okay? So you would circle what you want, write what you got, throw in a bridge, cross units opposite. It all works the same way. So I've got milligrams is what I'm looking for, and I'm going to start with 70.3 grams. And now I'm going to throw in a bridge, and I'm going to cross my units opposite. And I'm going from grams to milligrams. So I'm going to take a look at my conversion sheet, or hopefully you have it memorized, okay? So grams are base. Where's milli? 3, 10 to the third. Which one is bigger? Well, don't forget, when you're on this line here, and here's your base, this way gets smaller, okay? So if milligrams are here, and that's base, then that's getting smaller. Which one's bigger? Grams. That gets the 1. And the milligram gets the 1 times 10 to the third. Okay? So now my grams cancel out, and I'm done. I'm just going to multiply this. So go ahead and multiply that, and tell me what you get in your calculator. Scientific notation, if it's more than 10 to the third, we'll answer in scientific notation. So what are you getting? 7.03 times 10 to the fourth. Awesome. And now my grams canceled out, so I'm left with milligrams. If you don't get that, please make sure what you're typing into your calculator is 70.3 times 1E3, and then you're hitting the equal button, okay? So this is what you're putting into your calculator. Make sure you don't do times 10E, okay? All right, let's skip B. That's easy. Let's do this one. Let's do C. Circle what you want. So I've got kilometers squared. Write what I've got, 137,000 micrometers squared. Throw in a bridge and cross my units opposite, micrometers squared. So I know I'm going to kilometers squared. So let's come back to in our head, hopefully now. Where's micro? Micro's at 6. Good, micro's at 6. And where's kilo on the other side? 3. If they're on opposite sides, then it's 6 plus 3, which is 9. Good. Which one's bigger? Kilo is on the left here, and micro's on the right here. Which one's bigger? Kilo. So that gets the 1. And the micro is 1 times 10 to the 9. What's wrong, though? It's squared. If it's squared, guess what you actually need to do to your conversion? You need to square it. Here's why. If you're just doing a length, okay? If you're just doing a length and you want to convert it, and you're in micrometers and you want to convert it to kilometers, fine. You can just go ahead and convert it, and you figure out that it's 1 times 10 to the 9th, and you can do your conversion. But what is squared length a measurement of? Starts with an A? Area. Perfect. If it's cubed, what is it a measurement of? Volume. So if it's area, now we're looking at something like this, where we're looking at length times width, or something like that. So I can't just do one conversion. I actually have to do the conversion twice, which means you can do 2 of these bridges, okay? Or instead, what can I do to this right here? Just square it, okay? You would be squaring this, but what's 1 squared? 1 anyway, okay? So that you don't have to do. What is 1 times 10 to the 9th squared?
1 times 10 to the 18.
Perfect, that's 18 now, okay? So 1 times 10 to the 9th times 1 times 10 to the 9th. Someone raised their hand and they said, Ms. Ismail, I think you have it wrong. It should be 1 times 10 to the 81. No, you are not doing 9 times 9, okay? If you're confused and you're questioning and you're like, I'm almost positive my math teacher taught me that you multiply those two, you don't. What do? You add them, okay? If you're not sure, go ahead and plug it into your calculator just to make sure. So this will give you 1 times 10 to the 18th, not 1 times 10 to the 81, okay? So just to make sure that you do that correctly. When it's squared, you're just multiplying them. You are not going to, you can multiply these two together. Otherwise, you're adding them, okay? If it's written this way, you're adding them. Here, you can just multiply 9 times 2. All right, so now all you're going to do is you're going to divide by it. So in your calculator, what you should be typing here is 137,000, not times 1, but you don't have to do that, divided by 1E18. And please tell me what you get when you plug this in to your calculator. 1.37. Notice it did do your sig figs correctly. So we got rid of those zeros. Those zeros are not significant. If there was a decimal there, they would be significant, and you would have to include them. But those zeros are not significant. So 1.37 times 10 to the what? Negative 13. Awesome. And my units, my micrometers squared cancel out, and I'm left with kilometers squared. Let's come down to Q6 and try this one out. So again, I'm going to stagger a little bit. Go ahead and start working on it. And then if you get stuck, that's when you're going to start watching. But hopefully you don't. Hopefully you don't need me, okay? So I'm going to circle what I want. And in this case, make sure that you write it as numerator denominator. So pounds over gallons is what I'm going to write there. And then I've got 1.09 grams over milliliters. And it's important that you do not write your units together in the numerator line. If it's a denominator, you need to write it down on the bottom with the denominators, where the denominator goes. So now I'm going to throw in a bridge, and I can either start with my grams or my milliliters. Both of them need to be converted. So it doesn't really matter which one I start with. I'm just going to start with the grams. And I'm going to cross the grams opposite. There's nothing in this problem that's telling me anything. And I need to switch grams into pounds. Okay, so I know that's mass. Grams and pounds are both mass. So where do I go? I go to the conversion sheet. And on the conversion sheet, you're looking under the mass section. Okay? Now grams happens to be an SI, an international system. Pounds happens to be an English system. So if I want to switch grams to pounds, where should I go? English to SI. And do you see a conversion of pounds to grams, or the other way around? What is it? 453.6 grams. Awesome. So 1 pound, I'm going to come back to this now. 1 pound is equal to 453.6 grams. And my grams cancel out, and I'm in pounds, which is great. That checks. I don't want to cancel pounds out. So what I want to make sure that you don't do is cross pounds opposite. Because if you cross pounds opposite, what's going to happen? They're going to cancel out. We don't want to cancel them out. We want to keep pounds. And remember, singular, plural doesn't matter. People, persons, servings, a lot of times you'll see problems like that. They all mean the same thing, okay? So pound, pounds, it's the same. Now I need to cancel milliliters out. Where do you need to write it in order to cancel it out?
On top.
On top. So now I'm going to write milliliters opposite on top. And I'm trying to get to gallons, okay? In the shortest way, let's see if we could switch milliliters to gallons. I think would work.
Milliliters to liters.
Perfect. We could do milliliters to liters first, and then once we do that, we could do
Milliliters to gallons.
perfect, liters to gallons. Okay? So let's do that. So I'm going to have you help me with this. So now I'm in milliliters, and I don't want milliliters. And what was the conversion of milliliters to liters? Well, liters is base. Milli is at what place? 3. Good. 10 to the third. Which one's bigger? Liters. So that gets the 1. And then the 1 times 10 to the third goes with the milliliter. So my milliliters are canceling out, not my liters. And it's really important that you keep writing your units down and showing what cancels out and what doesn't. Otherwise, it will be a mess. Okay? So make sure that you do that. Now I don't want liters. So where do I write liters? Top. Because now the top is going to get it to cancel out. So you keep wanting it to cancel out. And what did they say about how many liters were in a gallon? It was 3.78 liters in 1 gallon. And now my liters cancel out, and I'm left with pounds right there and per gallon. Okay? If it's in your numerator, then that stays in your numerator. If it's in your denominator, it stays in your denominator. So you're actually getting pounds per gallon. In your calculator, remember to multiply before you divide. Okay, please tell me what you get when you multiply and divide. 9.083. Repeated. Okay, sig figs. Here we go. This has a decimal in it. That's telling us that they measured something, okay? So how many sig figs in this? 3. How many sig figs here? Well, there's another decimal. So how many sig figs there? 4. How many sig figs here? Infinite. Nice. This is a definition. This came from the middle section on the conversion sheet, and we said those were infinite. What about 3.78? I see a decimal in there. How many sig figs? 3. What is the least number that we have? 3. You want to round this to 3 sig figs, which gives us 9.08, and my units are pounds per gallon. Got it? Okay, and then let's try, I really like the pizza, and you know what, let's do the IV. Let's do the IV fluid one. Okay, so a patient's in the hospital, and they're given IV, and it delivers 1,000 cc. I see a number, I'm just going to underline it. It delivers 1,000 cc's of dextrose over 8 hours. So it's actually 1,000 cc's per what?
Hour.
Per
8 hours.
8 hours. Good. So I'm going to write this over here as 1,000 decimal point. They did actually measure decimal point. cc's per 8.0 hours. Okay, so we've got 2 things. We've got the 1,000 cc per 8 hours, then we've got 15 drops per cc. By the way, if you don't know what a cc is, my mother-in-law, for example, is from Europe. And when she came to stay when my son was born, she kept saying cc's, and I was like, cc's, I don't know what you're talking about. She's like, yeah, you can put about 250 cc's of water in there. That's about how much you need. cc is the same thing as a centimeter cubed. It's right here. So a cc is a centimeter cubed. And Europeans speak in cc's, okay? It's normal for them to say cc's. So, and they own a restaurant, and so they do everything in milliliters or centimeters cubed. What is that? 1 centimeter cubed of water, this is a milliliter. So just right at the bottom where like this red part sits on this graduated cylinder, that is 1 milliliter. This beaker right here is 150 cc's or centimeters cubed. If I were to fill it up with water, that would be 150 milliliters or 150 centimeters cubed. Or if your parents are doctors or physicians, you've probably heard that before too. If they're talking about something, or if you're in an office and they're talking about the IV fluids and they say the cc's, how many cc's of something. So it's just centimeters cubed. That's all that is. All right. So what are we looking for in this problem though? What's the question asking us for? In units, what is it asking us for?
Drops per
minute. It's asking us for rate, but rate's not a unit. So we're going to say drops per minute, and I'm going to write it as numerator denominator instead of writing it side to side. Okay? So if you're ending with 2 units, you need to start with 2 units. But if you look at this, I actually have 2 choices. The one thing that's going to make it easier though is, do you notice anything that's similar about one of them that might help us? The drops. What do you mean the drops?
It has the same.
It has the same unit. We're trying to end with drops per minute, and we already have drops per cc. So that might be a nice place to start, just because we already know that we have drops in our numerator, and we're done with that. So let's start there. And it's 15 drops, and whether or not that decimal is there, it's still 15. Numbers 1 to 9 are all significant anyway, right? So that's fine. So 15 drops per cc. So my drops are actually fine. I don't want to change that, because that's right there. But I do want to get rid of cc. So where do I write it? On top. Okay, and is there anything in the problem that you know about cc's that's going to help us here? And I already used this, so now what?
1,000.
Yep, the 1,000 cc's per
8.0
hours. So now my cc's cancel out. I'm not done because I don't want drops per hour. I want drops per minute. So I'm going to do one more bridge, write my hours opposite. And what do you know about hours to minutes? 60 minutes in 1 hour. And we're done because our hours cancel out and we're left with drops over minutes. Okay? So you're going to multiply and divide. So multiply, divide. So you should do 15 times 1,000 divided by 8, or 8.0, divided by 60, and then hit equals. And what do you get in your calculator?
31.25.
What is it?
31.25.
31.25. Thank you.
Well, she didn't.
Okay, sig figs. 15 drops per cc, to me, to say that you counted a certain number of drops would actually be no sig figs, okay? Because it's not something that is a measured value. It's not 15.22 drops, it's 15 drops. So I'm actually going to say that that's an infinite number of sig figs on that. Here we've got 1,000 and 8.0. 1,000 with the decimal point 4. The decimal makes those significant. How many in 8.0? 2. What about an hour is 60 minutes?
It's
That's infinite. That's infinite. That's by definition. So what's your least number? 2. So how are we going to round this to 2 sig figs?
31.
31. Awesome. And so our final answer is 31 drops per minute.